Welcome to the webinar, the Lux Sustainable Manufacturing Radar. My name is Anthony Schiavo, Research Director here at Lux Research, and I'll be moderating today's session. Presenting today is my colleague Akshay Chowdhury, an analyst here at Lux Research. Throughout this webinar, you can type any questions you have into the questions box on your screen. Time permitting, we will answer all the questions that we can. If your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com and we will respond. And with that, let's jump into the presentation.
Thanks, Anthony. Hello, everyone. Thank you for joining us for this webinar. As Anthony said, I'll be talking about Lux Sustainable Manufacturing Radar today. So for a couple of months, we have been receiving a lot of interest on sustainable manufacturing and questions around sustainable manufacturing from our clients. And those are mostly focused on what is sustainable manufacturing, how can they achieve it? And that basically inspired us to write this report as well as come up with a framework for achieving sustainable manufacturing and preparing a roadmap for sustainable manufacturing. So today I will talk about what is sustainable manufacturing, why you should care about it, how you can prepare a roadmap using Lux's Sustainable Manufacturing Radar, and some of the recommendation for successful implementation of the Sustainable Manufacturing Roadmap. So first, as you all know, that climate change is one of the major challenges facing the humanity. And if we want to restrict the Earth's temperature going up by 1.5%, we have limited carbon emissions. For example, here, to achieve that limit, we can only emit 420 gigatons of carbon emissions in next 10 years. And if you look at the contribution from the industrial sites, it's around 22%. So if you're thinking about net zero, the manufacturing will play a very important role. Similarly, there are other environmental impacts of manufacturing. For example, the water used in manufacturing is significant. Around 230 cubic kilometer water is used every year in manufacturing. Similarly, we have been extracting billions of tons of materials from the earth, and which has a huge impact on local ecology. And there is also a lot of hazardous waste being generated during the manufacturing process, which needs to be taken care of and which is also a costly process. So no wonder there is a lot of regulatory pressure. There have been policies developed by different countries to tackle this manufacturing and its impact on environment. Also, we see consumer preference changing towards more sustainable products, and also employee want to work for more sustainable companies. And it has a direct impact on the investment. So most of the investors are looking for companies with high environmental, social, and governance ratings, that is ESG in short. And also, due to the technological advances in digital transformation, we are seeing requirements for more transparency and visibility over the manufacturing operations. So that brings us to an interesting question, how we can achieve this and what exactly it means for sustainable manufacturing. So if you look at the sustainable manufacturing definition by EPA, it's a very broad set of different parameters, for example, environmental, social, and economic. And the current implementation of this definition, you will see that's mostly done through reducing the emission by achieving some energy efficiency, or maybe substituting the energy used by renewable energy sources, or maybe treating the wastewater or the other waste generated in the manufacturing, and maybe sourcing the materials from greener resources. But there is a bigger opportunity here. So if we want to exploit the full potential of sustainable manufacturing, I think we need to think beyond the existing ways, and we need to think about more novel processes, manufacturing processes, also redesigning the products for maybe circularity, and also valorizing some of the waste so there are enough economic advantages to generate new revenue stream. And further, it all needs alternative business models, basically scale some of these new innovations. And to help guide this innovation and its use for achieving sustainable manufacturing, we come up with a framework that basically maps all these different technologies and helps innovation leaders to prepare a sustainable manufacturing roadmap and basically prioritize some of the technologies needed for sustainable manufacturing. So when we are preparing this sustainable manufacturing radar, we took a very comprehensive life cycle thinking approach where we are not just focused on manufacturing and its inputs or outputs, but we are also looking at the other phases like the design phase, also the use phase and end of life. And we are looking at the impact of the other life cycle phases on manufacturing and also the impact of changes in manufacturing on the other life cycle phases. So, keeping that in mind, for developing this radar and or framework, we follow three steps. And the first step is basically selecting the indicators. Now, for most of the industries, these four indicators are common. So those are your GHG emissions, water intensity, material use, and waste generated during the manufacturing. So you can prioritize depending on the industry you are active in and basically select some of these indicators when it comes to achieving sustainable manufacturing. So to mitigate some of these intensities, we need to choose approaches, and we categorize these innovations to mitigate this intensity in three uh, under three approaches. So here, first one is improvement in operations. So basically, these are innovations where we are not changing the underlying processes, but we are more focused on uh, ad hoc technologies which can improve your efficiency, which can reduce the waste by optimizing the processes and improving the operations. But going beyond that, we are also looking at enabling circularity. So technologies which are necessary for recycling, remanufacturing, repairing, and basically they can reduce your waste and also valorize the waste. Here, one important point is we are not just looking at the industrial waste, but we also consider the implications for end of life and post consumer waste, because there are new regulations like extended producer responsibility uh, regulations, which are basically impacting the polymer manufacturers in Europe, and similar uh, regulations are being considered around the world. So finally, we look at the transformation in manufacturing, where we are looking at innovations which can fundamentally change the manufacturing process, or you can achieve that through changing the products or redesigning the products. And for to that to happen, we also need new business models. So keeping this in mind, uh, we need technologies to achieve this approach mitigation of these indicators through these approaches, three approaches. And to prioritize those technologies, we consider two factors. One is the maturity. So under that, we look at the technologies from lab to the scale stage. And also we are looking at the potential impact of these technologies in terms of their potential to reduce the four indicators we talked about. And I would like to just highlight here that this is a qualitative indicator because the impact will depend on the application, uh, depends on the industry where we are applying this technologies, and also the the other factor which plays an important role at what scale we are implementing these technologies. So combining all these three factors, all these three steps, we evaluated 20 technologies and come up with a sustainable manufacturing radar. So here you can see that we are looking at four indicators, three approaches, and the technology maturity and its impact. So under improve operations, there are technologies which are basically improving the operations by, let's say, uh, by increasing the efficiency through IoT or advanced analytics. In enabling circularity, we looked at advanced uh, advanced uh, recycling, plastic recycling technologies, also carbon capture and utilization technologies. Under transformative technologies, these are more long-term solutions, but also there are some mature technologies like 3D printing and bio-based materials. And basically, all this will help you uh, achieve sustainable manufacturing. And further, I would like to highlight few examples, basically how we can use some of these technologies to achieve sustainable manufacturing. So the first example is of digital product passport and how it can be used for waste intensity reduction. So in any recycling or remanufacturing applications, it's important to know the exact condition of the product or the its status and its material composition when it comes to recycling. So digital product passport is important because it records the information from the life cycle of the product, and basically that information will help guide the recycling and remanufacturing operations. So here VTT, which is one of the research institutes in Finland, is working on this, developing a framework for digital product passport, and also they plan to develop a minimal viable product through collaboration with external partners. And the objective is basically to gather the information and use that information to reduce the time required for assessing the remanufacturability of the product, as well as the time, the cost associated with the transportation of this remanufacturing operations. So definitely, this is a very new technology still emerging, and there are several challenges. And I think one of the major challenges from the data sharing perspective. So on one side, we can look at the technology hurdles, for example, data consolidation. But on the other side, when it comes to data sharing, not every supplier is ready to share data. And that can create a huge problem outside Europe where there are no regulatory pressures on sharing the data for digital product passport. So all this needs to be addressed before scaling this technology. The next example is from the water circularity. And here we talk about the membrane take, which is a fairly mature technology and being used at scale in different industries. But if you look at its potential impact, it's very high. And one of the reasons for that is uh, it, it can actually reduce the energy required in the recycling process. For example, here in pulp and paper industry, the black liquor is one of the uh, challenges where there's a lot of water contained and it needs to be separated uh, before evaporating the final water content from the black liquor. And so to separate that water from the black liquor, bioseparations uses graphene oxide coated membranes, and basically that reduces the water content, and the energy required for evaporation of the remaining water content, it reduced by 50%. And because of this, if we gain in efficiency, the output increases by 3 to 10% in the factory. Now we have seen it's being applied in pulp and paper industry, and also there's a potential for this technology to be used in other industries, heavy industries like chemicals and materials. So when we are looking at circularity, we need to also look at the operational side of circularity and how we can reduce the energy consumption in those operations. Moving forward, here the third example I would like to highlight from the more transformative changes in manufacturing, where we are looking at 3D printing and how it can reduce the material intensity. So in conventional processes, manufacturing processes like milling, there are challenges in terms of the shape which you can achieve, and that restricts you to specific designs. But 3D printing has no limitation in terms of shape, uh, but to maintain that structural integrity and at the same time reducing the material intensity is a difficult task, and it needs to go through certain uh, uh, processes like topology optimization. And so here the example, you can see the RUAG used a finite element analysis to optimize the uh, product shape and basically reduce the material intensity by 40%. One thing you can observe here is the absolute material reduction is very minimum. And if you want to scale this 3D printing applications in other products or other industries, we need to have innovative tools like generative design or maybe developing new materials through material informatics. So for now, we can see there are some niche use cases, but if it has to grow, we need to think about the ecosystem of tools necessary to enable 3D printing and also reduce the material intensity. So based on this examples as well as the manufacturing radar, uh, we have a few recommendations. So the first one is about the digital transformation and how it relates to sustainability. So far, we have seen most of the digital transformation projects focusing on improvement in operation or maybe use of robotics to increase the productivity or worker safety. But we need to think beyond that. We need to think about how it can enable circularity and transformative changes. For example, looking at more performance based or outcome based business models through digital tools, or also looking at more uh, sustainable manufacturing approaches like gaining the visibility of your processes and uh, creating a high impact technology for those specific problems in your operations. So you need to link your your sustainability KPIs with digital transformation effort. So far, if you have been tracking the energy efficiency or maybe productivity, you need to also include the sustainability KPIs like material intensity, water intensity, and waste intensity when you are tracking using these digital tools. The next one is, so far we talked about technology, but there is another aspect, which is a people aspect. And many mature technologies we have seen in the digital space failed because of the lack of focus on cultural change throughout the organization. So similarly, in sustainable manufacturing, we need to have that alignment across the strategy, execution, and the technology aspects of implementation of sustainable manufacturing. And for that, we need a clear vision, which is being communicated from top level to the shop floor when it comes to achieving sustainable manufacturing. And also, there is a need for training of employees to enable sustainable manufacturing, tracking of those KPIs, and incentivizing those efforts and setting a clear objective for sustainable manufacturing. And basically, after implementation and going through all this process, all this setting up of objectives as well as clear uh, communication, we can think about even more and look at the customization of sustainable manufacturing radar for your own applications. So, for example, here there are several factors which actually play a role in sustainable manufacturing, and it vary across geography as well as the industries. And when it comes to developing your own sustainable manufacturing radar, you need to take all this consideration. For example, what is the technology maturity in your organization? What is the digital maturity in organization? And when you're thinking about a particular technology, you need to also think about the adjacent technology which is enabling those technologies. So having that portfolio approach uh, through this sustainable manufacturing radar is very important. Finally, just to summarize, as we are going through this transition in manufacturing, we need to think beyond improvement in operations. We need to be proactive when it comes to enabling circularity or transformative changes so that in the long term you can have that competitive advantage. Also, for achieving that, we need integration across your organization of around the uh, data sharing, also your projects where they are tracking KPIs related to sustainable manufacturing. And we need that collaboration within the organization as well as externally with your suppliers when you're uh, thinking about sustainable manufacturing. And finally, there is a need for new business models. So the current business models are mostly volume based, and how the increase in consumption leads to more revenues. But we need to think beyond that and perhaps look at the outcome based business models or also waste valorization uh, type of business model where you one's waste is someone else's uh, resource, and also through that you can generate new revenue streams. So with that note, I would like to conclude my presentation and happy to take any questions if you have any.
Thanks, Akshay. We're now going to begin taking questions. Again, you can type those questions into the question box. If we don't get to your questions on the call, someone from Lux will be in touch after the webinar. So Akshay, while we're waiting for the questions to come in, I have a question of my own. You talked about how there's these 4 KPIs that we used sort of as the baseline. But I'm curious, what other KPIs are out there? And there's a pretty wide range of businesses in the industrial segment. What are some of the other KPIs that you think are important for companies to consider in their sustainability planning?
Yeah, I think that's a very interesting question. So if you look at the three aspects of sustainable manufacturing, one is the economic, the other one is environment and the social. So we talked about more of economic and the environmental aspects, but we can also think about more environmental aspects. For example, land use, which is one of the big concerns when it comes to mining industry, or and its subsequent impact on the material sourcing for all the manufacturers. And also there is a whole new or whole uh, altogether different set of parameters when it comes to social indicators and social aspects of sustainable manufacturing. In that, you can also track basically employee safety, the product safety, and the impact of your manufacturing on the local locality around your manufacturing facilities. So I think these are some of the key sustainable manufacturing KPIs you can look for when you're thinking about some of the other uh, KPIs.
Yeah, I think that's really important. I was just reading a story recently about how NASCAR races using leaded paint, or excuse me, leaded fuel, really affected populations around them. It's just now beginning to have, the consequences be fully understood. So, you know, we divided the radar up into these different sections, enabling, improving operations, enabling circularity, these transformative processes. And it seems like companies are fairly good at improving efficiency, but enabling circularity, these new transformative technologies, these seem much more challenging. Do you have any advice for companies, or you know, why do you think that is, and how would you consider tackling uh, those technologies in those circular or transformative sections?
Yes, definitely. So I think there are two aspects. One is on the technology side, the other one is on the more of economic side. So for the technology side, I think when it comes to scaling some of these technologies, uh, we need more collaboration to basically accelerate the R&D efforts around some of these emerging techs in advanced recycling, or maybe in the more transformative ways, for example, electrification of steel production. So that's technological aspects. But on the other side, when it comes to economic, I think uh, there's a significant need for new business models, and basically waste valorization is one of them. Also, having that collaboration, for example, in case of industrial symbiosis, working together with your with other industry partners, or uh, companies from other industries, and see that synergy between the waste and how it can be valorized. So I think that two important points, one on the more of technology side, where you need more integration, more scaling capacities. On the other side, on the economic side, where you need to have that collaboration to basically enable these new business models.
Okay, we have a question in here in the chat. Basically asking, you called out these three technologies. Are these the most impactful technologies, or if so, what do you think is the most some of the most crucial technologies across this whole radar?
So I think that depends on what stage and what industry you're looking at.
Hmm.
So in many industries, for example, who have low carbon emissions or low scope 1 carbon emissions, for them, focusing on maybe energy efficiency like scope 2 and also the scope 3 emissions, it's important. And some of the technologies there are mostly related to how you get the data from suppliers, how you track your supply chains and make sure that your carbon footprint is low. So on that side, having that digital product passport may be a more crucial technology for them. But when it comes to the scope 1 heavy and industries, and that they are not meeting their targets, if we look at their projections, I think for that we need more transformative technologies like, let's say, molten metal oxide, where we are electrifying the steel production process. Of course, there is a lot of research and optimization needs to be done, but depending on the industry, I think these priorities will vary. And that's the whole point, where basically you can use this uh, sustainable manufacturing radar. You can plot all these different technologies and see their comparative performance and select the most effective technology for your company and your industry.
So I think that's a great segue, because we have time for one more question, and um, uh, there were a couple questions. How can you modify the radar? What would you suggest? Changing the KPIs, changing the factors you scored. How would you go about customizing the radar for a specific industry?
Yes. I think the process we explained, like the three-step process, it covers all the aspects of customizing the radar. So, for example, when you're choosing your indicators, you can modify them according to your industry or your geography, and the priorities can vary in terms of indicators there. So, also when it comes to approaches, you need to have that comprehensive view of sustainable manufacturing, where you're not just looking at the low-hanging fruits, but also maybe have a more comprehensive understanding of sustainable manufacturing in time, and also the time frame where you want to achieve those targets. So for that, you can think about the immediate technologies in improvement in operations, or more towards in the midterm around circularity, and maybe in the long term along the transformative changes. And finally, I think uh, it's important to see the technology maturity within your organization. And that also, if you're already working on some of these pilot projects on the technologies listed, you should consider that, factor in those aspects. And also, the other aspect you can consider is the scale at which you can implement that at effective cost. So considering this parameter, you can customize by following the three steps we explained while developing the framework.
All right. Thanks, Akshay. That concludes our webinar for today. The slide presentation, as well as the recording from this webinar, will be sent to all attendees via email. After leaving the webinar, you will be prompted to complete a survey on today's presentation. We appreciate any feedback so that we can inform and improve future webinars. Also, take a moment and check out our upcoming webinars. Again, thanks for joining us and have a great day.
Thank you.